25th. In this video, I'm going to talk about angles, radians, and introduce you guys to something called the unit circle. All right, goal for today is to understand how to measure angles with radians. Why are we doing this? Radians are more useful in a lot of trig situations than degree measure. And we're going to need both of those to help us fill out our unit circle. So first question, what are angles? Got a bunch of angles up here. You might recognize some of them as being either acute or right or obtuse. But angles are a kind of difficult thing to define. I think we all know what they are when we see them. It's just a measure of how two lines intersect, but I want a more precise definition moving forward. And this is the definition you should add into your notes. Hopefully you've got your notes open, today's date written in there. And now copy this down. So an angle is a measure of rotation from an initial side to a terminal side. Angles are a measure of rotation from an initial side to a terminal side. And so when we define angles like this, that opens up the door for something like a negative angle. If we designate this as our initial side, we could say this isn't 90 degrees, but this is negative 90 degrees. It also opens the door for over-rotated angles. Instead of this being maybe 30 degrees, maybe we rotate it a full time around and this is 390 degrees. But it can get a little bit confusing with this whole initial side, terminal side thing, especially when we have negative angles, because if I reverse the two, then a positive angle would become a negative angle. So we're going to start drawing all of our angles in something called standard position. Go ahead, sketch this into your notes there. And a key feature of standard position is that your initial side is always anchored at the origin. And it extends along the positive x-axis. And then it can be rotated to our terminal side. An important thing here is that counterclockwise rotation is considered to be positive rotation. We'll just say counterclockwise positive, clockwise negative. All right, and so you look, there's going to be an angle marker, and you look to see if it's going up first or down first, and that will tell you if it's positive or negative. This one's going up first. We got to this terminal side by lifting up from that initial side, so this is a positive angle. All right, so what is a radian? So I think we're all familiar with what a degree is. We designate a full rotation as 360 degrees, and then any fraction of that, we can just take a fraction of 360 to get any other measurement. But a radian doesn't rely on this sort of arbitrary number of 360 degrees. A radian is a ratio of the length of the initial side and the length of the arc traced while rotating to the terminal side. And I wrote this a little bit backwards. It's actually the arc length divided by the initial side length that gives you radian. So we'll just write that as a formula, make it clear. It's arc length over, we'll say side length. Hopefully that's clear. All right, so really, we can figure out this ratio for a half circle really easily if we know the following formula. So for a circle, the circumference of that circle is equal to pi times its diameter. All right, and the diameter is 2 times the radius. Let's actually label all this stuff. Diameter, circumference. All right, so the circumference of a circle is equal to pi times its diameter. So let's imagine starting our angle in standard position. We put our initial side length right along that x-axis. I'll just draw it slightly elevated here. We rotate this initial side a full 180 degrees. And the very tip of that arrow is tracing out this half circle as we come over to here. And that's where our terminal side ends up. What is the ratio of this length out here to this length that we started with here? Well, this length that we started here, if we realize that this just traced half a circle, this would be the radius of that circle. And the arc length we just drew out is half a circumference, so it's 1/2 the circumference. This gets a lot easier if you just say, okay, I want the radius to just be 1 unit. We'll say all half circles are similar, so they're going to grow proportionally. So if this is just 1 unit, then the circumference would be pi times 2 times 1. The circumference would be equal to 2 pi. But this is only a half circle here. So if a full circumference is 2 pi units, then a half circumference equals just pi units. All right, but we knew, just because we know a thing or two about degrees, that this was 180 degrees. And so this is a really convenient conversion to memorize, is that 180 degrees is equal to pi radians. All right, now a note on radians here. We'll often say radians or just the word rad, but you technically don't have to write anything, because if we go back up to the definition, this is a ratio of side lengths, so any units would cancel out. This is actually a unitless measure of degrees. So if you just see a number, it could be an angle measure, but we don't have to write radians. But with degrees, you have to put that little circle, because this is a measurement of angle that does rely on a unit. This is unitless, and because of this pi in this formula, most radians have pi somewhere in that. So if I see an angle measure like 3 pi over 2, that pi there tips me off that this is a radian angle measure. I don't have to see that word rad at the end. All right, so let me just put that in and say most radian measures have pi. All right, so how do we convert an angle measure that's in degrees into radians, or vice versa? Let's start with the degree one here. I've got negative 100 degrees. What I need to do is I need to convert this into radians, so I want to multiply by a ratio of degrees to radians that I know is true. And I just gave you one that's really easy to memorize. 180 degrees equals pi radians. All right, so this is true. Pi radians does equal 180 degrees. So this is a form of 1. Anything divided by itself is a form of 1. It's just expressing the same angle in two different ways. So this isn't going to change the value. Plus I put degrees on the bottom so that degrees will now cancel out. All right, let's simplify this here. I've now got, I guess I can write it off to the side here, negative 100 pi over 180, no more degree symbol. We can write the word rad here if we want, but we don't have to. And now let's simplify that numerical part. I'll do it first by getting rid of a 0, so negative 10 pi over 18, then dividing the top and the bottom by 2. We get negative 5 pi over 9. And then you can write rad, but you don't have to. All right, so we just converted negative 100 degrees into radians. We know that, so let's convert back. We know this is in radians because we see that pi there and we don't see the little degrees. This has to be in radians. So going to again multiply by a form of 1. This time let's flip it upside down. Let's put the 180 degrees on top so we end up with degrees as our unit, and we'll put pi on the bottom. All right, at this point the pi's can cancel out. We got a pi on top, a pi on the bottom. Multiply across the top, we get 25 times 180 degrees equals 4,500 degrees divided by 12. Let's see if that 12 divides in evenly. It does. This here becomes 375 degrees, and we do have to write that little degree symbol. Okay, so that's how we convert. New word, coterminal. So coterminals are two angles with the same terminal side but different measures. So how is that possible? Well, let's just draw an angle in standard position. We'll start from this green line, and I'm going to rotate that green line around this way until it ends in the second quadrant here. All right, so that's one angle measure. I'm going to use theta for angle measures. But there was a different way to start from this green line and end up at that red line. I could have used a negative angle and rotated my initial side clockwise to end up there. So this is a different angle, theta, so we'll call it theta sub 2. This will be theta sub 1. They both have the same initial side, same terminal side, but they have different measures. All right. Are there only ever two coterminal angles for any angle? Nope, because we can over-rotate. If I wanted to end up at this same red line here, I could again start at that green line, and I could just rotate a full time around and then another portion around and still end up at that red line. I can actually rotate as many times as I wanted, still end up facing that same direction. So if anybody snowboards, doing a 360 and doing a 720, you still face the same way when you're landing. So those are coterminal tricks. All right, are these angles coterminal? Is rotating 35 degrees the same, or will land you at the same spot as rotating 1,475 degrees? Well, what we can do is take the difference. So the difference, 1475 minus 35, or you could do it the other way around. It actually wouldn't matter. 1475 minus 35, we get 1440. All right, and then we want to see if the difference is a multiple of 360 degrees, which is a full rotation. So then we divide by 360 degrees. So I've got 1440 over 360. Divide this by 360. And I get 4, exactly 4. So if their difference is a multiple of 360, then their difference is a multiple of exactly, in this case, 4 full rotations. So if this is an integer, they are coterminal. And this will tell you how many full rotations separate them. All right, so these two angles are coterminal. That's the same amount of rotation. What about these two? 7 pi and negative 15 pi. Again, I want to take their difference, 7 pi minus a negative 15 pi, and get 22 pi. But now I want to divide by whole rotations, a whole rotation in radians. Let's say we said a half rotation was pi, so a full rotation must be 2 pi. 2 pi radians for a full rotation. So I'll take the 22 pi divided by 2 pi. Pi's cancel out, and I'm left with 11. This is an integer. So these are coterminal, and they're separated by 11 rotations. So let's say yes to this one as well. All right. Find the measure of the angle given the reference angle. So the angle marker that starts on the initial side and ends at the terminal side is the angle that we want. We want to know how much rotation happened along, well, in this example, the red arrow. But we are given a little reference angle, which shows either how much rotation is left or how much past one of our axes we've gone. Here we see this terminal side has been rotated around a full time, plus another half time, plus a little bit more, and it stopped pi over 6 radians short of reaching the negative y-axis here. So what we want to do to find this is you want to count using pi if we're dealing with radians. So check what unit your reference angle is given in. If it's given in radians, then use radians. Count, so follow the rotation and count using pi for every half rotation. So here I've done pi. I come around, this is 2 pi. All the way to this point here is 3 pi. All right. And then you want to see if you want to over-rotate or under-rotate. Or we can just fill in this piece here. So I know that a half rotation, or half of a half full rotation, a 90-degree angle is pi over 2. So that's a good one to know. 90 degrees equals pi over 2. So this full amount right here would be pi over 2 radians. But I've backed off a little bit. I've backed off pi over 6 radians. So I could say, all right, so following my spiral, I'm at pi, 2 pi, 3 pi, 3.5 pi, or 3.5. 3.5 is the same as 7 over 2. So I'm at, if I go past my terminal side, all the way to here, I'm 7 pi over 2. And then I need to back off this pi over 6. So 7 pi over 2 minus pi over 6. Got to get a common denominator here, so I'll multiply the top and the bottom of this one by 3. 21 pi over 6 minus pi over 6 equals 20 pi over 6. And then that can be simplified to my final answer, 10 pi over 3. All right. And if it helps, I think that was maybe a little confusing where that 7 pi over 2 comes from. Let's count only half rotations or quarter rotations as pi over 2, and let's see if we can get to 7 pi over 2. So again, I started here. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. So it checks out. Then we had to back it up that much. We get 10 pi over 3. All right. I'll finish the first part of this video by just trying these 4 here. I'll just do it by myself. You should pause the video now, sketch these, see if you can find the measure of each of these angles shown in red on your own. I'm going to show my work here. So try them on your own. All right, and that is all four of those. A few tips on this is treat everything as if it's positive until the very end. So this one here, I said it was 540 degrees to get to this point, and then I went 10 more. But at the very end, I added in this negative because I saw I was rotating clockwise. My very first move was down along the spiral. Over here, I rotated 3 pi and then just added in my reference angle because the reference angle is included in my actual angle. And here I rotated 3 pi and then subtracted away the reference angle because the reference angle is not included in this rotation. So I went 1, 2, 3 pi, backed it up, and then at the very end made it negative because my first move was down. All right, we'll call that good for this first part. I'll be coming back with part 2.